Previously on Grasses and Classes. Smooth cordgrass, known scientifically as Spartina alterniflora, is an emergent plant. We plant Spartina alterniflora in living shorelines for three main reasons. It acts as a habitat for small animals, it prevents erosion, and it filters and absorbs pollution. We also learned about our local watershed. A watershed is an area in which all water, sediment, and dissolved materials drain from the land into a common body of water, in our case, the Choctawhatchee Bay. Finally, we learned about salinity. We used refractometers to measure the salinity of different waters in parts per thousand. What exactly is meant by parts per thousand? What do we mean when we talk about the concentration of a substance in a solution? Tune in to the second lesson of Grasses and Classes to find out. Welcome to Grasses and Classes, brought to you by the Choctawhatchee Basin Alliance and AmeriCorps Northwest Florida Environmental Stewards. This is Lesson 2, How Substances are Measured in Water.
Welcome back, explorers. Last lesson, we measured the salinity in water. Do you remember what salinity is? What tool can we use to measure salinity? Pause the video now to discuss. Salinity is the measure of salt in water, and it can be measured using a refractometer. When salt dissolves in water, a solution is created. A solution is when two or more substances are mixed together and then evenly distributed. Can you think of some other solutions? Pause the video now to discuss.
Solutions can include drinks like chocolate milk and salt water.
Basically, a solution is when we mix two ingredients together. The concentration of those ingredients is determined by how much we use. For example, we measure the concentration of salt in our brackish water solution in our nurseries when we use our refractometers.
Let's take a look at another example of concentration. Here we have Kool-Aid. Kool-Aid is a solution of Kool-Aid powder and water. The darker the Kool-Aid, the sweeter it will taste. This is because it has a higher concentration of Kool-Aid powder. Oh no, I added way too much Kool-Aid powder to my drink. Now it's way too sweet. The concentration of the Kool-Aid powder is too high. So what can I do about this? Pause the video now to discuss.
I can dilute my Kool-Aid by adding water. Dilution is the process of making a liquid thinner or weaker by adding a substance. When I am diluting my Kool-Aid, I am decreasing the amount of Kool-Aid powder in comparison to the amount of water.
How does the concentration of salt change in our nurseries when we dilute it with fresh water? Pause the video now to discuss. When we dilute the brackish water in our nurseries, this means we reduce the concentration of salts, which means we decrease the salinity. Why are substances measured in water? It doesn't necessarily take a lot of a substance to have an effect on the water. Substances in water are measured in parts per billion, parts per million, or even parts per thousand. Let's go look at an example.
Chlorine is added to our drinking water to clean it. The level is kept between 0.6 parts per million and 1 part per million. This is an extremely small amount. What do you think would happen if we stopped measuring the concentration of chlorine in our drinking water? Pause the video now to discuss. Too much chlorine will be harmful to our health, and too little would allow bacteria to grow in the water. Choctawhatchee Basin Alliance and AmeriCorps Northwest Florida environmental stewards monitor our bay. We keep track of substances in our water. What substances do you think we measure in our bay? Pause the video now to discuss. We monitor dissolved oxygen, sediment, and salinity, among other things, in our local waterways. This helps us keep track of how healthy our water is and how it is affected by changes in our environment. Small changes in our waterways can have big effects, just like a tiny change of only 1 part per million of chlorine in our drinking water can be harmful to us. Let's look at some examples so that you can see how small 1 part per million really is. 1 part per million is 1 3-ounce chocolate bar on a football field. It is 1 pinch of salt in 20 pounds of potato chips. 1 penny out of $10,000. 1 12-ounce can of soda in a 30-meter swimming pool. We measure salinity in our nurseries in parts per thousand, so let's take a look at that. What does it mean when we say that our salinity level is 10 parts per thousand? That means that out of the 1,000 parts in the solution, 10 are salt. How many are water? Pause the video now to discuss. With 10 parts of salt, there would be 990 parts of water in our solution.
Today we're going to do an experiment. We're going to make a solution out of food coloring and water. We will dilute this solution with more water to see how the concentration of the food coloring changes. Your teacher might assign jobs to people, or they might decide to do the activity themselves and pass the cups around to show everyone. Each class should have 6 sample cups that we will be putting the solutions in. Each solution will have a different concentration of food coloring depending on how much it is diluted. I will take you through each sample, but feel free to pause the video whenever needed. To begin, put 1 drop of food coloring into cup number 1. Then add 9 drops of water from cup A. Swirl it around to make sure that the solution is evenly mixed. Now let's pull out our worksheet for the activity that looks like this.
How many drops of food coloring did you put in sample 1? 1. How many drops of water did you put in sample 1? 9. How many total drops of food coloring and water did you put in sample 1? 10. The concentration of food coloring would then be expressed as 1 part per 10.
Now let's do sample 2. We're going to use our second pipette to get some of the liquid solution from cup number 1. We're going to put 1 drop into cup number 2. Make sure to put the rest of that liquid back into cup number 1. And we're going to use the water from cup B to rinse our pipette. You can do it a couple of times. All right. Then we will want to use cup A to put 9 more drops of water into cup 2. Swirl it around again to make sure it's evenly mixed. And now we can look at sample 2 on our activity sheet.
You can see we already have part of it filled in for you. The first blank is for the concentration of sample 1, which was 10. The second blank is the total drops in the new sample. We had 1 drop from sample 1 and 9 drops of water, so that equals 10 drops total. 10 times 10 equals 100, so the concentration of sample 2 is 1 part per 100.
Now we will do the same for sample number 3. Let's get some liquid from cup number 2. 1 drop into cup number 3. The rest goes back into cup number 2. Use cup B to rinse your pipette out. And then get water from cup A to add 9 drops into cup 3. Swirl it around again, evenly mix that solution. And we can already see it's getting lighter. Now let's look at our worksheet for sample 3.
Like before, you can see we already have part of it filled in for you. The first blank is for the concentration of sample 2, which was 100. The second blank is the total drops in the new sample. We had 1 drop from sample 2 and 9 drops of water, so that equals 10 drops total. 10 times 100 equals 1,000. So the concentration of sample 3 is 1 part per 1,000.
Now complete the rest of the samples and the worksheets on your own.
At the conclusion of the experiment, you should have 6 cups of water that look something like this. The cups with the darker water have a higher concentration than the lighter cups. This is because as we added more water, we were diluting the solution. Now that we're done with the activity, let's look at the questions in your student folder.
Well, explorers, I hope you enjoyed your second lesson of Grasses and Classes, where you learned how substances are measured in water. Until next time, keep exploring.